Hello and welcome to today's webinar, Game Developers Create Great User Experience with Amazon Cognito Sync. Before we begin, let's work through a few housekeeping items. On your screen, you can see a Q&A pod. Please submit your questions for our presenter and moderator at any time. We will address them throughout today's presentation as well as a live Q&A session in the end. At the conclusion of today's presentation, there will be 3 poll questions proceeding in live Q&A. Today's webinar is being recorded, and we will send you a follow-up email with the URL to the recording once we verify the recording quality, as well as a link to the presentation deck. And again, welcome to today's webinar, Game Developers Create Great User Experiences with Amazon Cognito Sync. Our presenter today is Steve Johnson. Steve is a solutions architect with AWS. He helps customers with their mobile development needs. With us today, we also have Dave Baruzzi, Software Development Manager for Amazon Web Services Mobile, and Rahul Sharma, Senior Dev Manager of Cognito. Dave and Rahul will engage with you and answer your questions throughout today's presentation while Steve presents. Steve, welcome. I now pass the floor to you.
Thanks, Bowen. I'm Steve Johnson, and thank you for attending today's webinar. We're going to be talking about Amazon Cognito Sync, specifically with applications toward mobile game development. So let's get started. Things we'll cover today, I'm going to talk about Amazon Cognito for those of you who may not be familiar with it, talk about some use cases for synchronization, how the features of Cognito support that. We'll dive a little deeper into the data model for Cognito Sync, how to use it with some code examples, and then some cookbook examples and best practices. So Amazon Cognito was designed to help mobile developers with a couple issues we saw they were having. And it's broken down into 3 categories. The first is identity management. One of the great things about Amazon Cognito is it allows you to authenticate your users using existing identity providers. For example, we support things like Google, Facebook, Twitter, Digits, and we even allow guest access. So you can manage your users whether they've logged in or maybe they haven't decided to log into your app yet. Second item is secure AWS access. And unfortunately, something that's become an anti-pattern in mobile development past couple of years is developers embedding credentials inside their apps. Now, this is a bad idea for a lot of reasons, especially since on certain platforms it's not that hard to decompile the code and get access to these credentials. So Cognito will actually give you a time-limited scoped permissions to the AWS cloud, and we do that through another service called the Secure Token Service. So basically, this allows you to have credentials to access all of your AWS assets, or ones you choose, obviously, and you don't have to worry about key compromise or embedding permanent credentials inside your app. The third area, and the one we're going to talk about the most today, is data synchronization. The great thing about Cognito Sync is it's cloud-based. Everything is sitting in the Amazon cloud. And because it's in the cloud, you have a lot of control over that data, either inserting it, synchronizing it, and really dictating a really good user experience for your customers. So let's talk about that. So some reasons why you would sync as a mobile game developer. Well, as you know, mobile developers are addressing customers that have more than one device. In fact, those devices may be shared with more than one user. So now you have a problem of a many-to-many mapping between users and their devices. And doing data management for a good customer experience is difficult in that environment. Second thing is users prefer to do something once. If I set a preference once, I expect that app to remember my preference. If I get to a certain level in a game, I expect to be able to continue where I left off, regardless of which device I'm using. Nobody wants to switch from a phone to a tablet, for example, and have to re-enter their preferences and start the game over from the beginning. And lastly, because these are mobile devices, users transition in and out of connectivity. Any kind of database or sync solution has to take into account the fact that the device may or may not be connected and needs to be able to sync whenever connectivity exists. Okay, some of the data we're seeing mobile developers use with our sync service. As I mentioned, user preferences. For example, if somebody likes playing the game with the volume off, you can sync that with the cloud. Metadata like high scores and unlocked levels, which are useful for things like leaderboards and things like that. And lastly, game state, or where you left off. So Cognito Sync actually lets you store complex data inside of the cloud. So you can put a game state there, or you could actually implement something similar to Amazon's Whisper Sync. If you're not familiar with that, it's a feature of our e-readers, where if you leave off on chapter 3 on one device and you want to finish reading the book on your phone, the next time you connect, it'll tell you, well, you're actually on chapter 3. Do you want to continue where you are, or do you want to use the save state? By using callbacks inside Cognito Sync, you have the ability to control that experience the same way. Okay, so how did we implement this? What is Cognito Sync? At its heart, Cognito Sync is a data store. It's a cloud-based data store with APIs that allow you to manipulate that data. Okay, the data store is implemented as key value pairs, and our SDKs allow you to work offline. So inside your mobile app or inside your game, you can get and set data elements inside your store, even if the device is offline. When it's connected, you can sync and resolve the data differences there. It's cross-platform, not just across devices, but across platforms. So if you have users that are on Android devices, iOS devices, or even using web applications, they all have access to that user's data store. Like the rest of AWS, data is private, so the only people with access to this sync data are the developer who owns the account and the individual who logged in. So all of our data is private. And lastly, Cognito is a fully managed service, and what we mean by that is we will handle all the back end for you. You don't have to instantiate any servers. You don't have to deploy any software. Everything you can do in Cognito is available through APIs and our SDKs. So let's look at that data model for a second. You'll see to the right there's a hierarchy of objects there, and way at the top is the foundation for all of Cognito's usage, which is an identity pool. So an identity pool is a logical boundary around a set of identities inside your AWS account. So most developers select an identity pool and map it directly to one of their apps, but there's nothing preventing you from using the same identity pool on multiple apps if you want users to share data across your apps. Not surprisingly, inside an identity pool are identities, and an identity maps to an individual user. Okay, this is part of Cognito Identity. Cognito Identity can federate users across different identity providers. So not only do your users have a choice of how to authenticate with your app, Cognito is smart enough to recognize when users are actually the same person and merge their identities that way. Identities can also be guest users. So Cognito can create identities for anonymous users as well. Okay, so each identity has a data set in the cloud, and these data sets contain up to 1 megabyte of information. So each identity has up to 21 megabyte data sets, and the reason we split it up into 1 megabyte data sets is this is the most granular level of sync. So when you sync, let's say you only change one thing in your application, it will only sync the data set that is changed, which will save you bandwidth and sync calls. And lastly, you have the concept of a record. Inside a data set, you have 1 to 1024 records, and these are key value pairs that are storing text. So how does this work? In the lower left-hand corner, you'll see what that rectangle represents your mobile app. And the first step would be for your users to authenticate. As we mentioned before, you can choose which identity providers are allowed in your identity pool. So you can log in through Google, Facebook, Twitter, Digits, Amazon, or even a custom authenticator. But for our example, let's say you authenticate through Facebook. you're going to get the Facebook OAuth token, and you're going to send that to Cognito. If this is the first time Cognito's seen that token, it's going to create a new identity and get credentials for it. If it already exists, it'll look up the identity and get you credentials for that. So you pass it in, the OAuth token from Facebook, for example, and you'll get back the Cognito ID that maps to that identity and your temporary credentials. I should also mention that those credentials, the permissions of those credentials, are determined by you, the developer. By default, those credentials will allow your users to use our mobile analytics service and allow you to use Cognito Sync. So those are available without any further configuration. So now that you have these Cognito credentials, you can call any service that's permitted by those permissions I just talked about. In our case for today, we're going to be talking about sync data and the sync data service. You simply create a client inside your app to synchronize the data. You update your data set and call synchronize, and that gets pushed up to the cloud. So let's take a look at some code that actually executes that. And what we're seeing here is an example from our Android SDK. And the first object you're going to create is something called a credentials provider. And the credentials provider is a container for your credentials. And when you create the provider, it'll actually interact with the Cognito service and get you your ID and your credentials for you. So it's really easy to get up and running. Once you have this provider, this object represents your credentials and your identity. So now let's use the Cognito Sync client. We're going to create a Cognito Sync manager called Sync Client. And as you can see in the constructor, we're passing in the provider. Okay, so now we have a sync client that knows who you are and where your identity pool is. And so now we're actually going to execute a sync. We create a new data set or an existing one. We have one called opener create data set. So if it exists, that'll be returned. If it doesn't, it'll create a new one for you. And those are all referred to using a name, a string. Once you have that data set, you can put records inside that database just like it was a dictionary or a map, right? So you dataset put my key, my value. Once you're finished working with your data sets, you can call the synchronize method. Now, the SDK is pretty smart, so when you call synchronize, the SDK knows which of your data sets need to be updated. The only thing you're passing in is a callback object. And your callback object is going to implement an interface. Okay, and the interface handles just about everything that can happen as a result of a synchronization method. So as you can see here, we have an onSuccess method, we have an onFailure method, we have one that resolves conflicts, one that calls you back if the data set's been deleted from the server, and one if Cognito Identity has merged two identities together and merged their data sets. You can get more information on that on the link at the bottom of the page. But I should say there's a default callback object you can use that just handles all of those events in a common sense way. Okay, so what's actually happening when you synchronize with the server? The first thing that the SDK does is pull the records from the server side using the List Records API. It then reconciles those records with your local store and calls any callbacks that are required, especially the interesting ones like conflict. From inside your callbacks, as I mentioned before, you can use default behavior or you can use custom code to resolve that any way you like, possibly even informing the user and letting the user make a decision about the experience they want. Okay? Once those are resolved by the callbacks, local updates are pushed to the service using the Update Records API. So to make this easier for you, we support several languages, including ones most popular with our game developers, things like Unity and Xamarin. We have iOS, including support for Swift, Android, of course, which we just saw, and JavaScript, which is useful for all sorts of platforms like web applications or even HTML5 applications. And we also have support for the Cognito Sync APIs and all of our server SDKs. So you can do server-side manipulation of these data records as well. Okay, so everything we've seen so far is pretty straightforward, right? We have data on our client, we're syncing with the data on the server, but we're actually in the AWS cloud, and since we're in the AWS cloud with this information, there's a lot of other features we've implemented to help you make really cool experiences for your customers. The first one is push sync, okay? So far we've been driving the sync operations from the client. You can drive the sync operations from the server as well. And this push sync rides on top of another AWS service called SNS, or a simple notification service. And the cool thing about SNS is it supports all kinds of endpoints. One of the endpoints it supports are mobile applications for our mobile push feature. So we support iOS, Android, and other messaging platforms like Baidu. We support HTTP, we support email. So if you want to push synchronization events from the server, you have a lot of options there. And you can look up all that stuff on our SNS product page if you want some more details. Next feature is something called Cognito Streams. And this addresses a problem a lot of our game developers have once their games become really popular. What was once a trickle of information that comes from these applications, from all the users playing their games, becomes a fire hose of information once you get up to hundreds of thousands or millions of users. And accommodating that data, processing that data on the server side had been really difficult. So we developed a service called Kinesis. And the best way to think about Kinesis is something like an elastic funnel. Okay? No matter how much data you put into Kinesis, it will scale and put all of that data into a buffer that you can operate on. So the Kinesis buffer is really interesting. It accommodates all the data we talked about. It keeps all of those messages in order so you can process those messages as they come in. And the time to live on that buffer is up to 7 days long. So you have a lot of time to work with this data. You can push it into Redshift, which is our data warehousing service. You can push it into S3 or Elasticsearch to search on it. Or you can make consumer processes that operate on the data while it's still inside the Kinesis buffer. This one's actually one of my favorites. It's Cognito Events, because it uses one of my favorite services, which is AWS Lambda. And if you're not familiar with Lambda, it's our serverless compute service. And the reason we call it serverless is when you use Lambda, you just create a function. So you upload code into the cloud, and you tell that function when to execute. In our case, a Cognito event occurs every time a synchronized event occurs in the cloud. So if one of your users attempts to synchronize their data, you can have a Lambda function process that data before it is stored in the cloud. And this gives us a lot of options and flexibility. For example, you can use that for data validation to prevent cheating. You can use it to inject data like in-app purchases or other content. And you can perform additional logic server-side during a synchronized call. So you have total control over this. You can delete all the data. You can insert all new data. You have full control over the data before it's synchronized. And as mentioned before, developers have access to the sync data across their account. So you can use the Cognito Sync APIs in your server-side applications or your desktop applications. It's also browsable from the console. So if you go to the AWS console and Cognito Sync, you can browse and manipulate the data directly from the web page. And then we'll see an example later of vending secured assets, which is really interesting. Okay, so that's what Cognito is and what Cognito does. How do I use it in my game? One use case we see a lot of is the need to synchronize more complex data. As I mentioned before, this is key value pair information that's being stored in the record. But of course, you can always serialize complex objects into JSON and store it that way. Works well for complex things like save games. And a record inside a dataset can be up to 1 megabyte in size, and that's a lot of JSON. If you have hierarchical data and you want to access it that way, you can use XPath-like keys for your record keys. And the nice thing about working offline with Cognito Sync is you don't have to do anything special. Okay, if you're not connected, each device, the SDK is going to maintain a local copy of that data store, and you can get and set keys without being connected to the cloud. We also have a special synchronized call that waits until you are connected before it attempts a sync. This will save CPU and power by waiting until the device is notified about connectivity before attempting a cloud sync. So what if you want to sync from the back end? Let's say you're using the Cognito Sync APIs from the server or from some other place in the Amazon cloud. You don't need to use Cognito credentials for this. Obviously, since you're in the back end and in the cloud, you can use your developer credentials. And you basically follow the same flow that the client follows whenever synchronizing the data. First, you make a call to list records. Then you manipulate the data any way you like, and then you perform and update records. Now the slide here is talking about something called sync count, and that's simply a serial counter that we keep as part of each record that maintains the number of times it's been synchronized. So internally we use sync count to make sure that you are synchronizing to the most recent version of that data. If you attempt to do a sync count with an obsolete version, it will throw an error. Okay, we get a lot of questions about syncing large files. So far we've been talking about key value pairs and data sets, but if you've got something really large, let's say a patch or a really large sound file or any other large binary data, you probably shouldn't be using Cognito for this. Instead, S3 is a really good solution for that. And the best way to use S3 with Cognito is to turn on bucket versioning inside your S3 bucket, store the files there, and make sure the sync file location and the version number of that file is stored in Cognito. So basically you're using Cognito as a metadata store for your large files. And you can set a lifecycle policy in your S3 bucket to make sure that although you're versioning your files and you'll always have a version number for that file, it only keeps one version at any given time, which is the most recent version, of course. So let's talk about handling conflicts when they occur. First, you'll probably only see this if you have multiple devices or you have things other than your client updating your data store. So the callback for a conflict, when you call synchronize, remember you're going to send in your callback methods. When you get a conflict callback, it gives you your existing data set and a list of conflicts. So the idea is to loop through all of the conflicts, and then you can resolve them with a local value, with a remote value, or a custom value. So let's take a look at what that looks like. So we're inside our conflict resolution callback right now. You can see the parameters being passed in are the data set and a list of conflicts. And it's not just a bunch of text. We actually have an object in the SDK called conflict. And the cool thing about the conflict object is if you decide to resolve with the remote record, for example, you simply call resolve with remote record on the conflict object. You don't have to look into the conflict. You don't have to parse any text. You don't have to do anything like that, right? So in the example here, you have a really good general purpose callback method which doesn't involve any introspection of the data itself. Okay, another conflict resolution case we see is if you have different state on the different devices in the same app. So let's say there's two devices running the app with the same identity, right? The person is logged into two different devices, but they actually have different state on those different devices for your app. The best way to handle that is to actually include the device name with the key in your data store. So in this case, if you have a key called gem, right, and you're getting conflicting data, as long as your values contain the name of the device, you should be able to compile those values into a single value, right? So here, local, I have device 1 is 5. The remote says somebody on device 2 has 20. I can consolidate those two values into a single value here using JSON. Okay, another use case is to prevent cheating using sync triggers. As I mentioned before, Lambda functions operate on data before it gets saved to the cloud. And you can put some heuristics in here that prevent, I guess, obvious cheating, right? If you know for a fact your game cannot amass more than 1 million points, right? You can test it and make sure that they don't have more than 1 million points. You can check timestamps along with some other values and eliminate some obvious cheating. We actually have a blog post on this topic. The link's on the slide right here. You can check that out. And we have an example here as well. This is actually written in Node.js. This is part of a Lambda function. And this is a good example of how to use Cognito Sync triggers, okay? So at the beginning of your Node.js function, you have an event. The event is actually a custom event in AWS that is called a sync trigger event. And it contains not only the data that's being synchronized, but some meta information as well, including the identity of the person calling it, the identity pool, things like that. So once we establish that this is a sync trigger event, we can take a look at the old and new values of a key called score key. Great thing about these Cognito Sync events, it gives you both the old and the new values, so you can tell right away changes without doing any further lookups. In our case, we're just making sure the new value minus the old value is less than 2,000 points. If it's more than that, we're just going to push the old value back into the data set. Okay? Nice thing about doing it this way, it's completely quiet. There's no notification that we think someone's cheating or anything else like that. An alternative for using the same approach is gathering data on your synchronization events. So we mentioned before you can use streams to push stuff into Kinesis, but you can actually do direct manipulation and storage of this information from the Lambda functions as well. Okay, another question that comes up once in a while is how to secure assets. Let's say you want to put something like an in-app purchase or something special inside your data set that was earned or purchased by your customer, okay? And you may want to put a little additional security around this. Now, there's a couple ways to do this, but if you want to put a secure asset in a data set, here's one approach for doing it. This is a combination of server-side operations and client-side operations, but the first step is to create a public-private key pair and distribute the public key with your app. So maybe when someone logs into your app for the first time, in addition to getting the identity, they sync to the cloud and they get a public key inside their data set. Let's say they make a purchase or they earn an achievement of some kind that you want to lock down. You create the asset record. And the asset record could be just a serial number of whatever this secured asset is. And you'll include the Cognito identity and possibly an expiration if this asset expires over time. From the server, you're going to sign this with the private key, which is stored on the server only, of course, and you can optionally encrypt it. Just signing it is good enough to ensure that it's not modified, but if you want to hide it, you can also encrypt it. So that signed and or encrypted record is put into someone's data set. Next time they sync, they will receive it. And so you can have your client use the public key, which is currently in the data set, to verify the signature and make sure they actually have access to this asset. And you can check identity ID against the currently logged in user. You can check the expiration time against the current time. And if everything passes, you can provide that asset. The last callback we haven't talked about is a profile merge. And this happens when Cognito identity merges two different authenticated identities together. So if you have one user who logs in on Facebook on one device, they log in, and then they choose to log in with Twitter, you can actually merge those identities together. into a single Cognito ID. And the merge process also merges their sync data stores together. So the concept here is to listen for that callback that you have a merged data set. You're going to open that data set and copy over anything to your new data set and then delete the merged data set. So basically the server will give you the merge of those two data stores, and it's up to you to manage that and create a new data set with the merged data. Okay, best practices, which is a summary of a lot of things we talked about so far. Only call synchronize from a single thread. Obviously, it's a network call, so do not call it from your UI thread. Don't call the synchronized data if you're unauthenticated. It's a good idea to reserve synchronize and data store for your authenticated users for a couple of reasons. First one is it encourages users to authenticate with your application. Second is data store costs money, right? So if you want to make sure that you have authenticated users using services that you're going to pay for. Use Cognito streams if you want to perform analysis on the data. Like I said, Kinesis provides a really good jumping off point for doing all sorts of analysis. One of the most popular things to do is put it into Redshift and do business intelligence type queries on the data. Store your large binary data in S3 with metadata in Cognito. You should always sync on app startup, obviously. And don't oversync. There's no reason, since you have offline access to the data, sync only at logical checkpoints, don't sync after every change. And push sync is a good idea if you want to reduce cost by reducing the number of syncs as well. Okay, as you already know, we have tons of technical resources online for all the services we talked about today. AWS Amazon.com/Cognito is a good jumping off point. Remember, when you're working with the APIs, we've split up Cognito into two APIs. We have Cognito Identity and Cognito Sync. For the stuff we talked about today, most of that is under Cognito Sync. And feel free to get help from the forums. There's lots of really smart people on there, both AWS and non-AWS, who can help you answer your questions. So speaking of questions, I think we're at the end of the presentation. So if you've been typing questions, moderators can push some of those if they haven't answered them, or maybe they have answered and they're just really interesting questions. They can push them over to me. Okay.
Sure. So we have about 25 minutes. So audience, this is a good chance for you to submit any questions. So Steve and our Q&A moderators will still facilitate questions in the Q&A pod, as well as pick some questions to answer verbally. And also, if you can take a moment to fill out the 3 poll questions to the left, that can provide the feedback on today's presentation. Thank you.
Okay, I don't see any.
So, I don't.
Okay, I'm looking at a few of the questions here. Can the API be called via Ajax? And the answer to that is yes, through the JavaScript API. So you should be able to use that from your web applications. Let's see. Can you store binary objects in Cognito? Yes, you can, depending on the size. It would have to be stored as text, though. You could always do a base 64 encoding if you want to do it that way. But anything that's truly binary and you want to, and it's larger than a megabyte, you should probably use the S3 approach we talked about. Okay, here's a question. Can I have my own custom login using Cognito? And the answer is yes. So when you're working with Cognito Identity, there's two ways to go about this with custom login. The first is Cognito will support any identity provider that uses OpenID Connect, and you can actually add that provider to your AWS account as an identity provider, and that provider will be valid across your account. Once you set up your identity pool, you can name that custom account as one of the allowed identity providers for your app. The second way to do it is, let's say you have your own database of users and passwords. There is an authenticated server-side call you can make in Cognito that will give you, that will basically give you credentials and tokens once you authenticate your users. So you would probably use your existing sign-on, single sign-on or authentication process you're using now. On the server side, once you have an authenticated user, you can notify Cognito and say, hey, I have this user. Please give me a Cognito ID for this person, and then you can get the credentials and pass it back to your app. Okay. Can I use Cognito for web applications? The answer is yes. Using the JavaScript API, as we discussed, you can sync it directly. Or you can use the server-side APIs to do your synchronization as well if you just want to make a web service API call to your server and have your server execute the Cognito Sync APIs. Okay, how long are the temporary credentials good for? They're good for an hour, but the credentials provider, in addition to being just a container for these credentials, will make the refresh calls automatically. So as long as you're working with our SDK, you should be able to use these credentials for the entire session. If you're using another identity provider like Facebook, you're responsible for keeping that token fresh, since we cannot authenticate Facebook for your user, obviously. That would be a bad thing. Okay. And that's all the questions we have. Okay. Let's see. Okay, another question popped up, a Windows Client SDK. We don't currently have a high-level client for Windows. There's no offline mode there, but we do have a C# SDK you can use with Cognito Sync. Another question, do we have plans for a sync framework for Dynamo DB and or RDS? And currently we don't support synchronization on those other databases. Okay, a viewer is asking about a sample Android app and cloud formation available, especially interested in best security practices with code examples. We actually have quite a few samples available on GitHub. Our group is AWS Labs. So if you browse over to the AWS Labs section of github.com, you'll see we have lots of Android examples. And the one I'm looking at right now is called Cognito Sync Demo. So that should help you out. Okay, if a user sets up a subscription using a Cognito identity and accidentally deletes their identity, i.e. identity provider token, what is the best practice for associating the orphaned account with the subscription? Okay, so let's talk about the way identities are stored for a second. If you have an anonymous user inside Cognito, you are responsible for maintaining the Cognito ID for that user. And the reason is pretty simple. Because it's unauthenticated, because it's anonymous, there's no way to look it up at a later date, right? Fortunately, the SDK manages that storage for you. So if you're using an unauthenticated Cognito identity, it will automatically be stored in the appropriate place on the platform. So Android, for example, it'll store that Cognito identity in Android's secure app space. If you're using an authenticated identity, you're also responsible for hanging on to that Cognito ID, but if that Cognito ID is lost, you can always look it up again by following the authentication process. So once you have an OAuth token from one of these identity providers, you can use that to get the associated Cognito ID at any time, provided that is still valid. If that token is not valid, you need to re-authenticate. Hopefully that answered the question. Okay, 2 questions. When will this be available as a recorded event, and where can I find this as a recorded event so I can work through it? You'll receive a follow-up email in a couple days with a link to the recording and also a link to the slide deck. So you'll have both the recording and the slides. Okay, will Cognito be useful when the game is a multiplayer game, syncing multiple users playing together? Okay. At this time, out of the box, data stored against an identity is only accessible to the owner and the developer. If you're going to share data, it's something you would have to set up on the server side. So for example, you could use Cognito events and Lambda to pull data from different users and store them in Dynamo DB. You could do it that way, or you could examine the data streams coming in through Cognito streams off of the Kinesis buffer and manage the data that way. So basically our priority, like all our services, is security, and we make sure only the user has access to their data as well as the developer. If you make a decision that you want to share that data across users, there's different ways to do that from the server side, nothing in the SDK right now. Okay, next question about something about SNS. Do I need to specifically do anything with SNS or the Cognito SDK for push functionality? In short, Cognito Push Sync handles a lot of it for you, but the full description is going to be in the documentation, which is under the Cognito section in the developer's guide. So in the Cognito developer guide, under Sync, there's a Push Sync section that talks about that in detail. Okay, is there an expected minimum client-to-client latency in a system that uses Cognito? We don't have a published SLA for Cognito, but once you sync, the data is immediately available to other devices. If you push sync, those latencies are comparable to latencies you would experience for Google or Apple push platforms. So if you're interested in latency, like shortest time to sync, push sync is a good way to go. If we use the JavaScript library, it would use local storage, one word, local storage for offline sync, and the answer is yes, it will use local storage. Okay, do all providers have to be set at create time? And what we're talking about here is setting the allowed identity providers for your identity pool. For example, can I start with Facebook and once the app is popular enough, add Twitter in later? And the answer is yes. So one way to do this, if you're playing around with Cognito or you're experimenting with the console, if you edit your identity pool inside the console, you will see tabs for each of the allowed identity providers, including the OIDC ones and your custom developer identity. And you can add those after create time. Okay, one question is about use of S3, and it says, how would we keep buckets distinct if we're making Cognito calls from our web server on behalf of a client? And we would suggest you only use one bucket. If you used fine-grained access controls on the role, the IAM role that accesses those S3 buckets, you can limit each identity to a specific portion of a bucket. So you can have one bucket and then use the fine-grained access controls to restrict access to individual users or behalf of individual users. Okay, a question about build platforms in Unity. Right now we support iOS and Android build platforms inside Unity. Okay. Any more questions? Okay, another question. Do you have a C++ API? No, we currently do not have C++ API at this time.
Okay, I think Steve has answered most of our audience questions. Same with Dave and Rahul has been answering questions nonstop in the back end. So I'd like to extend a special thank you to our presenter, Steve, for his time and a great presentation, and the audience for staying with us today. If you have any comments and suggestions on our previous or upcoming webinars, or suggestions on the topics which AWS may cover in future webinars, please feel free to email to aws-webcasts@amazon.com. Your feedback helps improve our webinar programming. Thank you to our audience for taking the time to join us today. Enjoy the rest of the day. Cheers.